So this is 3.4b, still doing theorems about zeros of polynomial functions, and we are on page 293. And one of the things that you've noticed is it's not always easy to find zeros of polynomial functions. When I've given you a polynomial function, holy cow, like 3x to the fourth minus 11x cubed plus 10x minus 4, and I say find the factors or find the zeros of this, even if I tell you to make it equal to 0, you're like, what the heck? Well, I could factor out an x cubed here and get a 3x minus 11, and then here I can factor out a 2 and get 5x minus 2. And then, does that help me at all? No, it doesn't help me in any way whatsoever. I can't go any further than that. Okay, so you can't always real quickly and easily be able to find the zeros of a polynomial. So that's where some tricks come in. Okay, so the rational zeros theorem says that if we take a p over q, okay, and the p would be the last number, and the q would be the first number. And we write this as negative 4 over 3. And if we write all of the possible factors of 4 and 3, in this case, what numbers multiplied together give me negative 4? Well, a positive 1 times a negative 4, a negative 1 times a positive 4, a 2 times a negative 2, so a positive 2 times a negative 2, or a negative 2 times a positive 2. Those are all my possibilities to multiply to get negative 4. Well, since these are the same, I don't need that one. So those are the possible answers or factors of negative 4. Fortunately, 3 is positive 1 times positive 3, or negative 1 times negative 3. Those are our only possibilities for 3. Alright, so if we want to find the zeros, all we have to do is try all of these combinations. Okay? So possibilities for p over q are, like I say, 1 times negative 4, negative 1 times 4, all of those possibilities. So plus 1, negative 1, plus 4, negative 4. Okay? All of these over 1 gives me those. Now if I took all of these over plus 3 and negative 3, I would get a whole bunch more. I'd get positive 1 over 3. I'd get negative 1/3. I'd get positive 2/3. I'd get negative 2/3. I'd get positive 4/3. I'd get negative 4/3. Okay? These are possible answers for this problem that I have right here. Okay, so let me reiterate this again. We take the last number over the first number, negative 4 over 3. We write all of the factors, all of the numbers that multiplied together are going to give me negative 4. So it's positive 1, negative 4, negative 1, positive 4, all those options. I write all of the factors of 3. Fortunately, 3 is prime, so I only have positive 1 times positive 3, negative 1 times negative 3. I write each one of the possibilities down here. So positive 1 over 1, negative 1 over negative 1, which is positive 1. Negative 1 over positive 1 is negative. So really I get 4 different options here, but 2 of them are the same. So actually maybe I should put that down here. So I have positive 1 over positive 1, negative 1 over negative 1, positive 1 over negative 1, negative 1 over positive 1. But notice, these two are the same, so I'm just going to write it as plus 1. And these two are both negative 1, so I just write it there. So even though I get 4 different possibilities, if they repeat themselves, then I don't have to put them all down. Or I'd have, instead of 10 numbers, I'd have 20. But they'd be all the same. 2 of them would be the same. I'd have 2 plus 1s, 2 negative 1s, 2 plus 4s, 2 negative 4s, etc. Okay, so these are my possibilities for answers. All right, so what do I do to find the answer? This is where I do synthetic division. And I try all of these numbers to see which ones are in fact factors. So I do synthetic division to see if I get a remainder of 0. If I do, then I want that one because it's a factor. So remember, I need to get this equation down to x squared with a bunch of things because I can use a quadratic formula to solve it from there. So this is 2 bigger than x squared, so I have to find 2 factors first, and then it's easy after that. So remember, you're just looking for how many factors above x squared this is. So this is 4, and so it's 2 bigger than x squared. So I have to find 2 factors here, or 2 zeros here, that are going to make this work. So I just have, what I would do is when I did synthetic division, I would start with the whole numbers and go from there. And then start plugging in fractions. But fractions in synthetic division don't sound like fun. Alright, so let's put our 3, negative 11, positive 10. Oops, don't want to get too much of a hurry there. Because I've got an x to the 4th, x cubed, x squared, x, and nothing. And I make that. Alright, so let's move this stuff up here. Alright, I'm going to turn this off. Okay, so there's my possible answers. There's my synthetic division. Alright, so let's start by putting 1 in here. So 3, negative 8, negative 8, negative 8, negative 8, 2, negative 2. Does not work. 1 is not one of the answers. Okay? So I can throw that out. Alright, so let's try negative 1. So that brings down my 3. This is a negative 3. Gives me negative 14, 14, 14, negative 14, negative 4, 4, 0. Yay! Alright, so negative 1 does work. Alright, so we're going to take negative 1 and put it here and say yay. Alright, so we've got that. Okay. Actually, I need to get my answer here. Alright, so negative 1 worked. So x plus 1 is a factor because, again, that negative means we're going to do the opposite. So x plus 1. And what do we have left? We have 3x cubed because we had 4. So we go down 1. Okay, so that's where we're at. Everything above here can go away except for this list of numbers. Alright, we already figured out that that doesn't work. That does work. Okay, we're going to try all these other numbers, and we start cruising along until we get a second one. Okay, it's in here somewhere. We just have to find it. So in this particular case, I'm just going to be nice to you and tell you that it's this number right here, 2/3. So let's do that. 3, negative 14, 14, negative 4, And we're going to put, I'm sorry, it's the negative 2/3. We're going to put a 2/3 in here. And get a different color here. 3. 6 over 3 is 2. Negative 12. Negative 24 over 3 is negative 8. That gives me a 6. 12 over 3 is 4. Gives me a 0. So I know that x minus 2/3 also works. So x plus 1 works. X minus 2/3 works. And that leaves me with 3x squared minus 12x plus 6. Alright, so now, why is this stuff not disappearing? Okay, so we have this right here. Now we can just use the quadratic formula and figure that one out. Okay, so factor out a 3 and then use the quadratic formula. And we end up with, when we do that, we've got our x plus 1, our x minus 2/3, factored out a 3, and we've got x squared minus 4x plus 2. Use the quadratic formula for that guy, and we end up with 2 plus or minus the square root of 2. Looks like fun, huh? So our final answer is 3 times x plus 1 times x minus 2/3 times x minus 2 plus the square root of 2 and x plus, actually it's x minus the quantity 2 minus the square root of 2. Okay, so this is the plus or minus right here. I was putting it there. So x minus x. Notice they're all x minuses except here, because this was actually an x minus a negative 1. So we made it a plus 1 there. And there is your factors to that long, nasty looking equation. So I'm going to stop here, and next video we'll do example 6.